Why, hello there. Today we're going to take a look at how to subtract linear expressions. Before we begin, I would like to start by reviewing how we add linear expressions. And I noticed the directions say use models if needed. We covered that the last time we were together. So I'm going to just use our algebraic method, which is going to be applying the distributive property. Remember that when we are adding linear expressions and we encounter parentheses, the parentheses can be removed by distributing a number into the actual value. So the number we're going to use is a 1. If you remember, this imaginary kind of 1 sits in front of parentheses always. So to distribute, we're just going to multiply. 1 times 3x is 3x, and 1 times 6 is 6. Also, 1 times 3x is positive 3x again. And 1 times negative 5 is negative 5, so I'm going to write minus 5. Notice, when I multiplied 1 times negative 5, my answer is negative, so I used a minus sign in my new expression. Now I want to combine my like terms, so I combine 3x plus 3x because they have the same variable pattern. And that gives me a result of 6x, and 6 plus negative 5, or 6 minus 5, is 1. So I write a positive 1. For number 2, we're doing the same thing. So I notice that I cannot combine my like terms because of parentheses. So I distribute my 1 through the parenthesis. 1 times x is x. 1 times 4 is 4. Now 1 times negative 2x is a negative 2x. And 1 times negative 6 is negative 6. So again, we're going to combine our like terms. So the x's combine. I have 1x, and I have to take away 2x's. So that's a negative x. And 4 minus 6 would be negative 2. So that's just a quick review of how we can add linear expressions. So I'm going to scroll down here to a couple of other examples. And what we're going to notice is that the pattern is the same. So I'm going to just rewrite this expression so I have a little bit more room. 6x plus 3. Notice now we are subtracting the next term. So the reason why this is significant is because I'm going to have to multiply by not just a 1, but a negative 1. So let's put this first 1 in here, and let's distribute. 1 times 6x and 1 times positive 3. But I'm going to use a different color here. This one is a little bit different. Notice there's a minus sign in front of it. So we have to take that with us, and we're actually going to multiply negative 1 times 2x. So negative 1 times 2 is negative 2x. See, negative 1 times 2x is negative 2x. And what happened is the sign flipped. Now negative 1 times positive 2 is also negative 2. And the reason why this is significant is because instead of trying to create models or try to do opposite operations, what we're finding is that we can just go ahead and we can distribute a negative 1, and it flips the sign of the numbers that are inside the second parenthesis. The next step is to still combine my like terms. So I have a 6x and a negative 2x, which is like saying 6x minus 2x. So we have 4 x's, and 3 minus 2 is 1. So again, it's the very same process. The only difference is we recognize that it is a negative 1 that we multiply by. Let's go to a different example. So we have 2x minus 3, and we're going to subtract x minus 2. So again, our 1 goes in front, distribute 2x. 1 times negative 3 is negative 3. Remember to take this whole negative, so negative x times, or negative 1 times x is negative x, and negative 1 times negative 2, negative times negative is positive 2. Combine like terms. 2x and a negative x is just 1x. Negative 3 plus 2 is negative 1. Again, notice this negative x just took x minus 2 and made it negative x plus 2. It flipped the sign of the second value. Sometimes we're going to encounter a problem where maybe the second term doesn't have a constant with it. So we still distribute. It's still going to be the same process. We have negative 2x minus 4, and we're just subtracting 2x. This would be like saying negative 1 times 2x. So we can write this as 1 times negative 2x is negative 2x. 1 times negative 4 is negative 4, and negative 1 times 2x is negative 2x. So we can still distribute it even if there isn't a second term in that second parenthesis. Remember to bring that negative with it, though. Negative 2x and negative 2x is negative 4x. And this negative 4 is just all by itself. So it's alone. So again, the process is very similar to what we have been experiencing. The only difference is that we have to make sure we're multiplying by that negative 1. Again, a similar problem to what we just saw. So what I would like to do is I would like to have you try this on your own. So pause the video, and you'll notice that you'll have to solve this, and then we'll check the answer in just a moment. Okay, so the way we want to solve this is we want to distribute our ones. So I am going to just rewrite this problem so it is something that I can work with. And let's use a different color so they stand out. So we put in our ones, and we want to distribute. So we have 1 times 6x, 1 times 5, negative 1 times 3x, and negative 1 times 1. Combine our like terms. 6x minus 3x is 3x. 5 minus 1 is 4. Did you get 3x plus 4? I hope you did. If you didn't, go back and look for a mistake. Perhaps you forgot to bring the negative 1 and carry it all the way through and change these signs. Or maybe the integers got you. But double check your work. Another example for us to try. So go ahead and set up your problem. Remember to distribute your 1 and your negative 1 through both parentheses, and then check your work. So here we go. We have our 12x plus, oops, I forgot my x. There we go. Plus 8, and we're going to subtract 6x plus 2. We're going to insert our ones. We're going to distribute. We end up with 12x. 1 times 8 is 8. Negative 1 times 6x is negative 6x. Negative 1 times 2 is negative 2. Combine like terms. 12x and negative 6x is 6 times x. 8 minus 2 is positive 6. Did you get 6x plus 6? I bet you did this time. Now we can also find a word problem to work with. So it says that a hat store tracks the sale of college and professional team hats for M months. The number of college hats sold is represented by 6M plus 3, and the number of professional hats sold is represented by 5M minus 2. They want us to write an expression to show how many more college hats were sold than professional hats. Then evaluate the expression if M equals 10. So some key things to look at here. They want us to write an expression. Don't just jump right to the answer. We have to write this expression. They want to show how many more college hats were sold than professional hats. So basically, we're taking college hats minus professional hats. So let's go back up into the problem. What can we use to represent the number of college hats? That would be 6m plus 3. So we write in 6m plus 3 minus the professional hats are represented by 5m minus 2. We still want to distribute our 1, so I'm going to put my 1 in front, and I'm going to distribute 1 times 6m, 1 times positive 3, negative 1 times 5m, and negative 1 times negative 2 is positive 2. When I combine my like terms, my 6m and negative 5m becomes 1m, and 3 plus 2 is 5. So this becomes the answer for the write an expression portion. That's my first answer. Now, we could label this maybe part A. Part B said to evaluate when m equals 10. So I want to take this expression of m plus 5, and I'm going to substitute the m with a 10. So 10 plus 5 is 15, and we're talking about hats. And that would be the answer to the second portion, which was to evaluate if m equals 10. So that's how we would solve a word problem. And again, it's the same process that we've seen where we want to identify what is the actual expression. We want to distribute this 1, all right, to get rid of the parentheses. We want to combine like terms. And then in this case, we substituted the value of the variable with a known value. Now, if at any point you have a question on this, please make sure that you review this video. Go back, look over some of the examples, and just double check some of the explanations. There are also some helpful hints located in our textbook. If you go into the textbook and you notice there's the resource section, there are tutor videos that will go through additional problems with you, and they will explain it to you as well. You can always email me. You can always check in with us in class. I hope this video helps you understand how to subtract linear expressions. Please remember that when you distribute to that second value, you distribute the negative 1. And that flips the sign of those numbers that are inside the parentheses. We'll see you next time.